In this lesson we're going to add and subtract radicals. Now adding and subtracting radicals is much like adding and subtracting variables. If I have 2x and 3x and I want to add them together, first of all I have to have like terms to do that. So if this is an x and this is an x, you're going to add the coefficients, and that's going to give you 5x. Well, adding radicals is very similar, adding or subtracting. But what we typically have to do first is we have to simplify our radicals and then add, subtract the coefficients of the like radicals, just like we do with variables, and we keep the radical the same, basically, just like we keep the x the same. So here's some examples down here. 18 radical 5 minus 12 radical 5. Our radicals are already reduced, and we have like terms because the radical 5 is the same as the radical 5. So all I'm doing is subtracting the 18, or the 12, from the 18. So it's 18 minus 12 radical 5, which ends up being 6 radical 5. So the radical 5 stays there. In the second example, we do have like terms, although I recommend that you simplify this out first. So let's simplify, or we could do it either way, but if I simplify this first, just in, because most of the time you won't have the same terms. This is radical 4 radical 6, so it's 2 radical 6 plus, over here it's 5 radical 4 radical 6, so this is 5 times 2 radical 6. So we really have 2 radical 6 plus 10 radical 6. And again, we're going to add the coefficients and keep the radical. So this ends up being 12 radical 6. So we simplify first, and then we add or subtract coefficients of like radicals, and then we keep the radical the same. So for the next one, the 7 cannot be reduced, but the 63 I can reduce down. So before I add them together, I have to simplify that second term. I have 4, and then I break up my radicals into 2. The largest perfect square that goes into 63 is a 9. 9 times 7. So I'm making my way to like terms. This ends up being the square root of 9 is 3. I have my radical 7. So finally, I'm to a place where I can add the coefficients. My radicands are the same. They're going to stay radical 7. I'm going to add the 12 and the 2. So this is 2 plus 12, all of that times radical 7, and we end up with 14 radical 7. So we can apply this to a couple of problems. If I want to find the perimeter of the triangle, that means I'm going to add up the 3 sides. So I want to add radical 12 to 2 radical 2 to radical 32. The problem is I can't add those. I don't have like terms yet. So I'm going to simplify the radical 12 and simplify the radical 32 and then see what we have. Radical 12 breaks up into radical 4 radical 3. The 2 radical 2 just stays the same. And radical 32 is broken up into radical 16 and radical 2. So now I have 2 radical 3 plus 2 radical 2 plus 4 radical 2. If I'm going to combine like terms, I can only combine the 2 radical 2 and the 4 radical 2 because these are like terms. The 2 radical 3 is just going to stay there. 2 radical 3, and this is the same as adding the 2 and the 4 with the radical 2. So the perimeter is going to be 2 radical 3 plus 6 radical 2. That's the most I can simplify it. You never add radicands together. You have to keep them separate. You treat them like variables. Alright, for the second one we want to find the area. So that's a little different. The formula for the area of a triangle is going to be 1/2 the base times the height. You can find the base and the height because they create a 90-degree angle. So I'm not even going to use this radical 174. I'm going to use radical 24 and 5 radical 6. If I do that, then my area is 1/2 times 5 radical 6 times radical 24. I'm going to keep the 1/2 there and see what happens to it in the end. I'll do the 1/2 last. So if I have 1/2, if I multiply the rest of it, I have 5 times radical 144, because 6 times 24 is 144. This happens to be a perfect square, so I don't do my two radical signs. That's what you have to remember when you have a perfect square. You take the square root, and it's 12. Now if I multiply all those together, I end up with 30. So that's an example of using the area formula with radicals. Finally, we'll determine the area and the perimeter of the rectangle. For the perimeter, we need to add all the way around, so I need this guy and I need this guy. If I look at 11 radical 3, he's already simplified, but it looks like my 75 I'm going to have to do something with. If I take my radical 75, I can break him up into 2, and he can break up into 25 and 3, so he is 5 radical 3. I need to put him over here, and my 11 radical 3 goes up there. Please remember to fill all that in, because when you find the perimeter, you got to add all the way around. So the perimeter is 11 radical 3 plus 5 radical 3 plus another 11 radical 3 plus another 5 radical 3. And that's going to end up being 32 radical 3. That's the perimeter. Now for the area, you only need to multiply 2 of them. I'm still going to use my simplified versions. The area is base times height, so that's going to be 5 radical 3 times 11 radical 3. 5 times 11 is 55. When you multiply radical 3 by radical 3, you end up with 3, because you're essentially squaring a radical. And then that ends up being whatever 55 times 3 is. That's going to be 165. And that's terrible looking 6. Let me fix that. 165 is your answer. So that's how we can use radicals, the same as any other numbers in problems with area and perimeter.